Hello everybody, it's Amel, and today I'm going to teach you how to solve find minimum in rotated sorted array. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. Example, this array might become this one, rotated. Find the minimum element. You may assume no duplicate exists in the array. So example 1, this is the input, and this is an array that is sorted but it has been rotated. So you see 1, 2, and then 3, 4, 5. And the minimum element is 1, so the method returns 1. Example 2, this is a rotated sorted array, so 0, 1, 2, and then 4, 5, 6, 7. And the minimum element is 0, so the method returns 0. So how can we solve this problem? The naive approach would be to iterate from left to right, keeping track of the running minimum, and whenever we see a new element that is less than the minimum, we update the minimum. The time complexity would be big O of n, where n is the number of elements in the array. So the time complexity would be linear. The space complexity would be big O of 1. Can we do better? Yes, we can do better. If we take advantage of the property that the array is a rotated sorted array, we can use binary search to obtain logarithmic time. So if we examine the middle element, for example in this case 5, and we compare the middle element with the last element, we know that the minimum element that cannot be here. The minimum element has to be in this portion, because if you examine the middle element and you see that it is bigger than the last element, that means that all the elements, that means that the smallest element in the array has to be in this portion, and it cannot be in this portion. So we can discard this portion and only focus on this one. And that's going to allow us to do binary search. Also, if the middle element is less than the last element, then the minimum could be the middle element itself, or it could be before the middle element. So we can discard the right portion and only focus on the first portion. So that's the main idea. So without further ado, I'm going to show you how to write the code. First, I'm going to have integer left gets a value of 0, right gets a value of nums.length minus 1, while left is less than right. While I'm looking at two different elements, I will get a middle point. Integer mid gets a value of left plus right minus left divided by 2. And then if num sub mid is greater than num sub right, in that case this 5 is bigger than this 2. That means that the middle element, the smallest element, has to be in this portion, in the right portion. So I can discard the entire left portion. So I will say left gets a value of mid plus 1, else that means that the middle element is less than the last element. So the middle element itself could be the smallest element, or a number before the middle element could be the smallest element. So I can discard the entire right portion. So I will say right gets the value of mid, because mid itself could be the smallest element, and at the end left is going to be equal to right, so I can return num sub left. So I will run the code. I will submit my solution. Alright, so this is working perfectly. The time complexity is big O log n, where n is the number of elements in the array. The space complexity is big O of 1. If you like this video, please press the like button. Don't forget to subscribe, and see you next time.